Okay, this one is Prob13-95, and so we come in and we're looking for the tension in the cable, so we're going to need to draw a free body diagram. So I'm going to draw a free body diagram of the ball on the top of the table. Here's the round table. This will be the ball just off in some odd spot, and there's a hole in the middle of the table, and the only forces that are acting on the ball is gravity, which points straight into the table, which will not be seen in this diagram because it's from the top down, and also the normal force back up from the bottom of the table from the table to the bottom of the ball. I can't show that one either, it's not in this diagram. So the only force that you'll see right here is the tension, which is called F in the problem, so I'm going to label this as F, and it points inward. Okay, they're giving me R and theta and that sort of thing. They give me the mass. They want me to find the tension in the cord at the instant, so it starts at some point in the instant when R is equal to 0.25. So because this is not an instantaneous problem, what I'm imagining that I'm going to do, as in all problems that are like this, is I'm going to find the acceleration. It would be great if it was constant, but it won't be. But I'm going to find the acceleration, and then I'm going to integrate the equations to get the speed or position or whatever it is I need at any particular time. So starting off with this, I come in and say, all right, let's use the R and the theta coordinates, which is not too difficult to do. So let's apply the forces and set it equal to mass times acceleration. So here we go. We'll do this. Okay, so in the radial direction, or the UR direction, the only force I have is F, and it's in the negative direction, so I have minus F. That's it. So that equals mass times the acceleration in the UR direction, which is R double dot minus R theta dot squared. Okay. Then in the theta direction, I have no forces, and that equals mass times acceleration in the theta direction, which is 2 R dot theta dot plus R theta double dot. Okay, so because this is a non-instantaneous problem, you should be expecting that you're going to have to solve a differential equation. And that's why the book gives you the hint of what to use. What I'm going to do is show you where that comes from, and maybe you can follow procedure, or maybe not, but you would learn these kinds of things in the differential equations class. If you just simply apply the trick, all you're going to do is say that at the end you're going to say that R squared times theta dot is equal to a constant, and then move forward. What I'm going to try and do is show you where that comes from, so that you can realize it's not magic. So what I'm going to do is I'm going to pick on the equation that comes from the theta direction, and I'm going to try and solve it. So what I have then is the equation 0 equals m. I'm going to divide through by the m, and I'm left with 0 equals 2 R dot theta dot plus R theta double dot. And then what I'm going to do is separate the variables. I'm going to put all the R things on one side and all the theta on the other. So I'm going to have a minus 2 r dot theta dot equals r theta double dot. Now to separate the things, I'm going to divide through by theta dot and divide through by an r. So when I do, I end up with minus 2 r dot divided by r equals theta dot, double dot, excuse me, divided by theta dot. Okay. So now what I'm going to do is simply integrate both sides of the equation. So when I do, I'll clean this up just a little bit and then put in an integral. So this would be a minus 2, minus 2 integral of, let's see, this would be, well, back up, let me put in one more step. Okay, so instead of the dot terms, I'm going to put in a time derivative. I'm going to write it out. So this would be a minus 2 over r dr dt. And that will equal, this is going to be 1 over theta dot times d theta dot dt. Alright, so now what I'm going to do is cancel the dt's, multiply through by them, and so what I'm left with on the left hand side, now I'm going to put in an integral, is a minus 2 integral dr over r, and then over here this is going to be the integral of d theta dot over theta dot. Okay, so on the left hand side, this isn't too bad to integrate. It's basically du over u, so the integral of that is going to be a minus 2 ln of r plus some arbitrary constant, I'll call it k. And then on the right hand side, it's basically the same thing. It's du over u. So it's the d of something over that same, so, well, that's just the ln of theta dot. And I don't need an arbitrary constant because I've already put one in on the left hand side. Okay, so now I'm just going to simplify this a little bit, and there's a property of logarithms. So I'm going to get rid of this logarithms by raising it to, well, first I'm going to get rid of that negative 2, so I'm going to just simplify this using a property of logarithms, ln of r to the minus 2 power. So that's what that negative 2 ln r becomes. It's ln of r to the negative 2 plus a constant equals the ln of theta dot. Okay, now I'm going to take the exponential of both sides. So this becomes e to the ln of r to the minus 2 times e to the k. That equals, on the right hand side, it would be e to the ln of theta dot. So e to the ln annihilate each other. They're essentially, let me make that better. They annihilate each other because they're inverse functions. So on the left hand side, I have r to the minus 2 multiplied by e to the k, and that equals, on the right hand side, again they annihilate each other, so I'm left with theta dot. Now e to the k is just a number, so I'm just going to call it c. So on the left hand side I have c r to the minus 2 equals theta dot. So that's the equation that they want me to use to complete this problem. So I come up here and looking for it. Okay. So that's what I have. I've got these equations. So what I need to do is I need to find, okay, my battery is just about gone, so let me pause this. Okay, hopefully I didn't lose too much from that recording. So I'm going to assume that everything is okay and just kind of pick up from where I left off. So essentially then we've got the F equal ma equations, and we have this equation that we derived that relates the r and the theta dot for any values. And it has this arbitrary constant c. So let's proceed with that. What we want to do is identify what the constant c is, and to do that they told us that at a particular radius, at the beginning essentially, r was equal to 0.5, and at that time the theta dot was equal to 1. So we can substitute that those values in. And calculate the value of c. So they said that when r was equal to 0.5, so at 0.5 quantity squared, the theta was equal to 1, and that will have to equal c, and so c is equal to 0.5 squared, a quarter. So c is equal to 1/4. Alright, so now we have that. What we're going to do is just simply plug in. Okay, what we're looking for is the force F. So in order to get F, we need to find the we need the mass, which we're given. We need r double dot, we need r, and we need theta dot. So the mass is 2 kilograms. So mass is 2. The problem statement tells us that it is being pulled in, the rope is being pulled in at a constant rate of 0.2. So the r dot is getting smaller, so it'll be a negative, and it is a magnitude of 0.2. If r dot is constant, then r double dot is 0. Now the only thing that's left is we need to find out what is the theta dot. And we have a formula for that. R squared theta dot equals a constant. We know what the constant is, so all we do is plug in the value that we have. So we're interested in theta dot when r equals 0.25. So let's write that down. R equals 0.25. And then we're going to plug into the formula for the theta dot. So we'll have 0.25 squared, r squared, times theta dot equals the constant. And we've determined that the constant is 1/4. So we can use this formula to solve for theta dot. So theta dot at the time that we're interested in is 2.25 divided by 1/8. So that would be, let's see, uh, 4. So theta dot is equal to 4. Okay, so then we'll take these values and plug into the formula for the force, and we'll find that minus F equals the mass, which is 2, times r double dot is 0, minus r is 0.25, times theta dot squared. So that's 16 divided by 4 is 4, times 2 is 8. So, and it's positive 8. Alright, so that's what the force is, positive 8. Positive means I'm right, I'm pulling it, which better be true. Okay, so that's the end of this problem.